Hello students, let us begin with the solutions to homework problems. First, when sun rises, the moon sets. One of the happenings will take place, hence or is exclusive here. Second, to apply for a driving license, either a ration card or a passport or both can be used. Here or is inclusive. Third, all integers are positive or negative. An integer cannot be both positive or negative at a time. Therefore, here or is exclusive. Now students, let us study about what are quantifiers. Quantifiers are phrases like there exist and for all. Another phrase which appears in mathematical statements is there exists. For example, consider the statement P, there exists a rectangle whose sides are equal. This means that there is at least one rectangle whose all sides are equal. A word closely connected with there exists is for every or for all. Consider a statement P. For every prime number P, square root of P is an irrational number. This means that if S denotes the set of all prime numbers, then for all the members P of the set S, square root of P is an irrational number. In general, a mathematical statement that says for every can be interpreted as saying that all the members of the given set S where the property applies must satisfy that property. We should also observe that it is important to know precisely where in the sentence a given connecting word is introduced. For example, compare the following two sentences. First, for every positive number x, there exists a positive number y such that y is less than x. Second, there exists a positive number y such that for every positive number x, we have y less than x. Although these statements may look similar, they do not say the same thing. As a matter of fact, one is true and two is false. Thus, in order for a piece of mathematical writing to make sense, all of the symbols must be carefully introduced and each symbol must be introduced precisely at the right place, not too early and not too late. The words and or are called connectives, and there exists and for all are called quantifiers. Thus, we have seen that many mathematical statements contain some special words and it is important to know the meaning attached to them, especially when we have to check the validity of different statements. Now, let us solve an example here. Identify the quantifier in the following statements and write the negation of the statements. First, there exists a number which is equal to its square. Second, for every real number x, x is less than x plus 1. Third, there exists a capital for every state in India. Now, let us look at the solution. First, quantifier here is there exists P. There exists a number which is equal to its square. Not P is there does not exist a number which is equal to its square. In the second case, the quantifier is for every. P is for every real number x, x is less than x plus 1. So, not P will be there exists a real number x such that x is not less than x plus 1. In the third case, the quantifier is there exists. Statement P is there exists a capital for every state of India. Not P is there does not exist a capital for every state of India. Now, let us study about implications. Here, we shall discuss the implications of if, then, and if and only if. The statements with if, then are very common in mathematics. For example, consider the statement are. If you are born in some country, then you are a citizen of that country. When we look at this statement, we observe that it corresponds to two statements P and Q given by P. You are born in some country. Q. You are citizen of that country. Then the sentence if P then Q says that in the event if P is true, then Q must be true. One of the most important facts about the sentence if P then Q is that it does not say anything or places no demand on Q when P is false. For example, if you are not born in the country, then you cannot say anything about Q. To put it in other words, not happening of P has no effect on happening of Q. Another point to be noted for the statement if P then Q is that the statement does not imply that P happens. There are several ways of understanding if P then Q statements. I shall illustrate these ways in the context of the following statement. If a number is a multiple of 9, then it is a multiple of 3. Let P and Q denote the statements P, a number is a multiple of 9, Q, a number is a multiple of 3. Then if P then Q is the same as the following. First, P implies Q is denoted by P implies Q. The symbol implies stands for implies. This says that a number is a multiple of 9 implies that it is a multiple of 3. Second, P is a sufficient condition for Q. This says that knowing that a number is a multiple of 9 is sufficient to conclude that it is a multiple of 3. Third, P only if Q. This says that a number is a multiple of 9 only if it is a multiple of 3. Fourth, Q is a necessary condition for P. This says that when a number is a multiple of 9, it is necessarily a multiple of 3. Fifth, minus Q implies minus P. This says that if a number is not a multiple of 3, then it is not a multiple of 9. Let us look into an example here. Rewrite the following statement with if then in 5 different ways, conveying the same meaning. If a natural number is odd, then its square is also odd. Look at the solution. First way, a natural number is odd implies that its square is odd. Second, a natural number is odd only if its square is odd. Third, if the square of a natural number is not odd, then the natural number is also not odd. Fourth, for a natural number to be odd, it is necessary that its square is odd. Fifth way is, for a square of a natural number to be odd, it is sufficient that the number is odd. So, students, today we studied about quantifiers and implications. It is time to note down the home assignment. Note down the question. Write each of the following statements in the form if then. First, you get a job implies that your credentials are good. Second, the banana trees will bloom if it stays warm for a month. Third, a quadrilateral is a parallelogram if its diagonals bisect each other. Fourth, to get an A plus in the class, it is necessary that you do all the exercises of the book. In the next session, we shall study about contrapositive and converse. Thank you.